For over 100 years, humanity has been calling out to the stars, announcing our existence and inviting contact with alien civilizations we know nothing about. And this might be the most dangerous thing our species has ever done. Tonight, we're going to explore the answer. Where are you listening from right now? Is your room quiet and dim? Or can you hear rain tapping softly against the window? Or maybe you're under a warm blanket while the world outside grows dark. If this quiet unease finds you and you want to understand why, reaching out to alien life might be more dangerous than staying silent forever. You're welcome to stay a little longer. Maybe leave a subscribe, a gentle like, or just listen. Let's begin and discover why first contact might mean last contact. Do you remember the first time you truly saw the stars? Not just glanced up while walking to your car, not through the glow of streetlights and city haze, but really saw them lying on your back in some dark field or quiet rooftop, watching the sky open up like a door you never knew existed. Maybe you were a child, small and unburdened, and the vastness didn't frighten you yet. Maybe you felt something ancient stir inside, some primal recognition that you were looking at something older than language, older than cities, older than humanity itself. And in that moment, a question bloomed in your mind, soft and inevitable as breath. Is anyone else out there? It's the oldest question we have. Long before we built telescopes or radio dishes, before we knew what stars even were, we looked up and wondered. Ancient humans saw gods and heroes traced in light. We told stories to fill the silence, invented companions in the dark, because the alternative, true, absolute aloneness felt unbearable. But now we know better. We know the stars are not gods, but suns. We know the Milky Way is not a river of milk, but a galaxy, a vast spiral of 400 billion stars, each one a furnace of fusion, burning across distances our minds cannot truly hold. And orbiting those stars' planets, trillions of them, worlds of ice and fire gas and stone, some perhaps covered in oceans, some wrapped in storms that have raged for centuries, some quiet and cold and waiting. The numbers are staggering. If you tried to count every star in our galaxy, alone one per second, it would take you over 12,000 years. And each of those stars statistically hosts at least one planet. Some have 2, some have 10. The James Webb Space Telescope has shown us worlds with atmospheres thick with water vapor, with chemical signatures that hint at life's possibility. We've found planets in the habitable zone, that perfect distance from their sun, where liquid water can exist, where life as we know it might take root. By every measure of probability, by every equation we can devise, we should not be alone. The universe is not a desert. It's an ocean vast and deep and teeming with potential. Somewhere out there on some world orbiting some distant sun, another being might be looking up at their own sky, asking the same question we are. The math demands it. The sheer scale of existence insists upon it. And yet when we listen to that ocean, when we point our most sensitive instruments toward the stars and strain to hear even the faintest whisper of intelligence, we are met with something far stranger than we ever anticipated. Not the voices of 1,000 civilizations, not the hum of interstellar commerce, or the digital chatter of alien societies. We hear silence, perfect, complete, unbroken silence. It's not the comfortable quiet of an empty room. It's the silence of a held breath, the silence of something waiting, and the longer we listen, the more unsettling it becomes, because silence, on this scale, across billions of stars and trillions of worlds, doesn't feel random. It feels chosen. It feels like a decision. Every night, somewhere on Earth, giant radio dishes turn toward infinity. In deserts and on mountaintops, these patient machines listen to the oldest music in the universe. The hum of hydrogen, the pulse of pulsars, the faint crackle of the cosmic microwave background, the afterglow of creation itself. Scientists sift through oceans of static, searching for one pattern that doesn't belong, one rhythm, shaped by thought, one signal that says unmistakably, we are here too. But the static never changes. The cosmos remains silent, indifferent, endless. This is not what we expected when we first turned our instruments skyward. When SETI, the search for extraterrestrial intelligence, began in the 1960s, optimism filled the air like champagne. We had just stepped into space ourselves, touched the moon with human hands. Surely we thought someone else out there must be trying to communicate. Surely we would hear something within a few years, perhaps even a few months. A beacon, a pulse, a message encoded in the mathematics of prime numbers. But decades passed. We built bigger telescopes, more sensitive receivers, faster computers to process the endless stream of cosmic noise. We scanned thousands of star systems. We listened across every frequency we could imagine. Still nothing. Some call it the Great Silence, others the Eerie Void. But it's more than just the absence of sound. It's the presence of a question so profound it reshapes everything we thought we understood about existence. Because if the universe is as full of life as the numbers suggest, then someone should be speaking. And if they're not speaking, we have to ask why. In 1961, a radio astronomer named Frank Drake sat down and did something remarkable. He tried to estimate, using nothing but logic and probability, how many intelligent civilizations might exist in our galaxy right now. The result became known as the Drake equation, and it's both beautifully simple and deeply unsettling. The equation asks, how many stars are there? Of those, how many have planets? Of those planets, how many could support life? Of those that could, how many actually do? And of those with life, how many develop intelligence technology and the desire to communicate? Even with conservative estimates, assuming life is rare, intelligence rarer, and the willingness to broadcast rarer, still the numbers are staggering. The Drake equation suggests there could be thousands of communicating civilizations in the Milky Way alone. Some optimistic calculations push that number into the millions. Even the most pessimistic scenarios, where we assume nearly everything has to go perfectly right for intelligence to arise, still predict dozens of technological societies scattered across the stars. But here's where the equation becomes uncomfortable. It doesn't just predict that intelligent life exists. It predicts that some of these civilizations should be far, far older than us. Our sun is relatively young in cosmic terms. The galaxy is over 13 billion years old. There are stars that formed and potentially birthed civilizations billions of years before Earth even existed. Think about what that means. If a civilization had emerged just 1 billion years before us, they would have had a billion-year head start on technology, on exploration, on everything. A billion years ago, on Earth, the most complex life forms were simple, multicellular organisms. Now, We've split the atom, walked on the moon, and sent machines beyond our solar system. Imagine what a civilization could accomplish with 1 billion years of progress. They should be everywhere. They should be impossible to miss. This is where Enrico Fermi's question becomes haunting. In 1950, over lunch with colleagues, Fermi did some casual, back-of-the-envelope calculations about interstellar travel. Even without faster-than-light technology, even moving at a tiny fraction of light speed, a single expanding civilization could colonize the entire galaxy in just a few million years. It's a slow process by human standards, but in cosmic time, it's nothing a blink a heartbeat. So Fermi asked his simple, devastating question: where is everybody? If intelligent life is common, if civilizations arise regularly, if even a tiny percentage of them develop the means to travel between stars, then by now, after billions of years, the galaxy should be teeming with evidence of their presence. We should see massive structures built around stars to harvest energy. We should detect artificial radio signals from 1,000 different sources. We should find probes in our own solar system, ancient and waiting, sent by explorers long dead. Instead, we find nothing. No megastructures, no signals, no probes, not even ruins. Just stars burning in silence, planets turning in empty orbits, and the faint hiss of radiation left over from the Big Bang. This contradiction, the high probability of alien life versus the total absence of evidence, is what we now call the Fermi paradox. It's not just a scientific puzzle, it's an existential mirror, reflecting back our deepest assumptions about life intelligence and survival in an indifferent universe. Over the decades, countless explanations have been proposed. Maybe life is extraordinarily rare, a cosmic accident so unlikely it happened only once. Maybe intelligence is the fluke, not life itself. Perhaps the universe is full of bacteria and algae, but consciousness is vanishingly uncommon. Maybe technological civilizations destroy themselves before they can expand, consumed by war or environmental collapse or some other filter we haven't encountered yet. Or maybe they're out there, but we're simply not looking correctly. Perhaps their technology is so advanced it's indistinguishable from natural phenomena. Perhaps they communicate in ways we can't detect, using quantum entanglement or gravitational waves or methods we haven't even imagined. Some have suggested we live in a kind of cosmic preserve, a galactic zoo, where we're observed but never contacted left to develop naturally without interference. But there's another possibility, one that's both simpler and more chilling. Maybe the silence isn't a mystery to be solved. Maybe it's a warning to be understood. Consider what we've actually observed. In the past few decades, we've discovered thousands of exoplanets, worlds orbiting distant stars. The Kepler Space Telescope alone found over 2,600 confirmed planets, and estimates suggest there are billions more in our galaxy. Many of these worlds orbit in the habitable zone, where conditions might be right for liquid water and potentially life. We've found super-Earths with thick atmospheres. We've found water vapor in alien skies. We've detected chemical biosignatures that on Earth would be unmistakable signs of life. The universe is not barren. It's abundant with the raw ingredients and suitable conditions for biology to emerge. Yet when we look for techno-signatures, signs of technology, of intelligence, of civilizations, we find absolutely nothing. No Dyson spheres capturing the light of stars. No artificial radio transmissions. No heat signatures from massive computing arrays. No light from sprawling cities on distant worlds. The galaxy looks, for all intents and purposes, completely natural, untouched, pristine. This absence is starting to feel less like bad luck and more like a pattern. As our technology improves, as our surveys become more comprehensive, the silence only deepens. We're not finding hidden signals we missed before. We're confirming again and again that the sky is quiet. And here's what makes that so unsettling. The quiet is too uniform, too complete. If civilizations were simply rare or short-lived, we'd expect to see something, perhaps the ruins of a dead empire, or the faint echo of a long silent beacon, or the residual glow of abandoned megastructures still orbiting their stars. We'd expect irregularity pockets of activity, traces of what once was. Instead, the galaxy appears to have been scrubbed clean. Every planet looks untouched. Every star system seems virginal, as if intelligence has never left a mark on them. The only two explanations for such thoroughness are that intelligent life truly never arises, which the numbers tell us is nearly impossible, or that something removes the evidence. Something ensures the silence continues. In the control rooms of radio observatories, this realization has begun to settle like frost. The scientists who spend their careers listening to the cosmos speak of a particular kind of unease, a feeling that grows the longer you stare at the data. It's not the disappointment of finding nothing. It's the creeping suspicion that the nothing is intentional, that the static you're hearing isn't emptiness. It's a choice made by billions of minds, all independently arriving at the same terrible conclusion: that in a universe where survival may depend on silence, revealing yourself is an act of suicide. Every new exoplanet we discover, every Earth-like world glowing faintly in the cold dark, only amplifies the paradox. These aren't just rocks orbiting distant suns. They're opportunities, chances for life to begin, for intelligence to evolve, for consciousness to look up and wonder. The galaxy is full of such opportunities, billions upon billions of them. Statistically, some must have succeeded. The math is undeniable. So where are they? Where are the voices? Where are the lights? Where is the empire that should have consumed the stars? By now, the network that should span 100,000 light years. The machines that should be everywhere. The answer, perhaps, is that they learned something we haven't yet. They learned what happens when you speak too loudly in the dark. They learned that in a universe where you cannot know who is listening, where distance makes diplomacy impossible and misunderstanding is fatal, the only rational choice is silence. The great silence seen through this lens is not a mystery. It's evidence. Evidence that intelligence, wherever it arises, eventually figures out the same brutal logic of cosmic survival. Evidence that the night sky is not empty, it's holding its breath. And we, young and loud and hopeful, are only beginning to understand why. But perhaps the silence isn't just absence. Perhaps it's the shadow cast by something we're only beginning to understand, a filter so deadly that most who encounter it never make it through. Imagine the history of life in the universe as a vast obstacle course stretching across billions of years. At the starting line stands simple chemistry, amino acids forming in primordial oceans, proteins folding in the warmth of volcanic vents. This is where it all begins. on countless worlds scattered across the cosmos. But reaching the finish line, becoming a spacefaring civilization capable of colonizing the galaxy, requires passing through a series of gates, each one narrower and more treacherous than the last. This is the concept of the Great Filter, and it may be the most important idea in all of astrobiology. It suggests that somewhere between the origins of life and the colonization of the galaxy, there exists a barrier so difficult to cross that almost no one makes it through, a cosmic bottleneck that ensures despite the billions of opportunities, intelligent civilizations remain vanishingly rare. The question that keeps scientists awake at night is simple and terrifying. Where is the filter? If it lies behind us, if the hardest steps are in our past, then we are the lucky ones, the miraculous survivors who already beat the longest odds. Perhaps the emergence of life itself is so improbable that it's happened only once. Perhaps the leap from single-celled organisms to complex multicellular life is a barrier that almost no world ever crosses. On Earth, single-celled life appeared relatively quickly, but it took nearly 3 billion years. 3 billion years for anything more complex to evolve. That's not a small delay. That's most of Earth's history spent stuck at a single level of complexity. Or perhaps the filter is consciousness itself. Intelligence might be evolution's rarest gift, a fluke so unlikely that despite billions of years and trillions of worlds, it sparks only once in a great while. After all of the millions of species that have existed on Earth, only one has ever developed language, mathematics, and technology. Only one has looked up and asked, why? That's a ratio that should give us pause. If the Great Filter is behind us, then we are alone. Not because the universe is hostile, but because we won the lottery. We are the exception, the single spark of consciousness in an otherwise dark and silent cosmos. It's a lonely thought, but also a hopeful one. It means we've already survived the hardest test. The path ahead, while uncertain, is at least open. But there's another possibility, darker and more urgent. Maybe the filter isn't behind us. Maybe it's still ahead, waiting like a trap we haven't yet sprung. Maybe every civilization that reaches our level of development eventually encounters the same fatal threshold, and almost none survive it. Consider what that would mean. Somewhere out there on worlds, we'll never see civilizations rose and flourished. They built cities, created art, developed science. They looked up at their own stars and wondered if they were alone. Perhaps they even sent out signals called into the void with hope and curiosity. And then, at some point in their development, they encountered the filter. Perhaps it came suddenly, a nuclear war that spiraled out of control in a matter of hours, turning their world into a radioactive wasteland. Perhaps it came slowly, a climate catastrophe they saw coming, but couldn't stop a centuries-long unraveling that choked their oceans and baked their cities beneath unforgiving skies. Or perhaps it came from their own hands, in ways even more insidious. Maybe they engineered a pathogen that escaped containment, or created an artificial intelligence that optimized them out of existence, or developed nanotechnology that consumed everything in a gray tide of self-replication. The methods don't matter. The result is always the same silence. A once-living world goes dark, its lights flickering out one by one until only stone and wind remain. The Great Filter doesn't announce itself. It doesn't arrive with trumpets or warnings written in the sky. It happens quietly, the way all extinctions do. One day, a species is thriving, expanding, reaching toward the stars. The next, it's gone, and the universe indifferent, as always, simply continues. The stars keep burning, the planets keep turning, and the silence grows deeper by one more voice. This is the nightmare scenario that haunts every conversation about the Fermi paradox, because if the filter lies ahead, then we are walking toward it right now. Every technological breakthrough, every leap forward in our mastery over matter and energy might be bringing us closer to the threshold that will determine whether humanity survives or becomes another fossil buried in cosmic time. Look at where we are. In the span of just 70 years, less than a single human lifetime, we've gone from the first nuclear weapon to having enough warheads to destroy human civilization several times over. We've altered the chemistry of our atmosphere, warmed our oceans, and triggered what some scientists call the sixth mass extinction. We've created technologies we barely understand and can't fully control artificial intelligence systems that learn and adapt in ways their creators didn't anticipate. Genetic engineering tools that can rewrite the code of life itself, and weapons that can strike anywhere on the planet in minutes. We tell ourselves we're being careful. We establish ethics committees and regulatory frameworks. We write treaties and sign accords, but history shows us something uncomfortable. Every powerful technology we've ever developed has eventually been used in the most destructive way possible. Dynamite, invented to build, became a weapon of war. Nuclear fission, discovered through pure scientific curiosity, became the bomb. The internet, imagined as a tool for connection and knowledge, now serves as an instrument of surveillance manipulation and division. The pattern is clear and consistent. We create tools faster than we develop the wisdom to use them responsibly. Our technological power grows exponentially, while our moral and political sophistication advances at best incrementally. This gap, this widening chasm between what we can do and what we should do, may be the filter itself. Perhaps every intelligent species reaches this moment. Perhaps there's something inevitable about the way consciousness develops. First comes curiosity, then tool use, then science, then industry, then the harnessing of fundamental forces. Each step builds on the last, accelerating, compounding, until suddenly a species finds itself holding powers that were once reserved for gods. The ability to split atoms, the ability to edit DNA, the ability to create minds that think faster and more clearly than biological brains ever could. And perhaps at that moment, most species fail, not because they're evil or stupid, but because the challenge is simply too great. The jump from tribal creatures concerned with the next meal and the next shelter to cosmic stewards capable of managing planetary scale systems and existential technologies. That leap might be too far for evolution to bridge. Our instincts, honed over millions of years for survival in small groups, may be fundamentally unsuited for the decisions we now face. We fear strangers because for most of our history, strangers were dangerous. We compete for resources because scarcity was the default state of existence. We think in short time horizons because our ancestors who worried about things decades away were outcompeted by those who focused on surviving until tomorrow. These instincts served us well in the savannah. They may kill us in the stars. And the cruelest part, is that we might not even know when we've crossed the threshold. The filter might not be a single event, a war, a plague, a runaway AI, but a slow slide into dysfunction, a gradual loss of coordination, a fracturing of societies, a retreat into tribalism and short-term thinking precisely when we need global cooperation and long-term planning the most. We might be living through the filter right now, watching it unfold in real time, mistaking it for normal political turbulence or temporary setbacks, rather than recognizing it for what it is, the test that determines whether we survive. The great silence suddenly looks different through this lens. It's not just the absence of others, it's the memorial to those who came before and failed. Every silent star system might once have hosted a civilization that reached this same crossroads and chose wrong, or simply couldn't choose at all. The void we hear when we listen to the cosmos isn't emptiness. It's the accumulated weight of billions of years of failure, world after world going dark, each one a cautionary tale we can't hear. But here's the thing that makes this more than just cosmic horror. We don't know for certain where the filter is. We don't know if we've already passed it or if it still lies ahead. And that uncertainty might be the only thing that could save us. Because as long as we don't know, we have to act as if the filter is ahead. We have to assume that every decision we make about nuclear weapons, about climate change, about artificial intelligence, about how we treat each other and the planet that sustains us, every one of these decisions might be the one that determines whether humanity becomes a voice in the cosmos or just another silence. The filter doesn't care about our hopes or our potential. It doesn't grade on a curve or give second chances. It simply is a boundary written into the logic of the universe, sorting the survivors from the doomed with perfect mechanical efficiency. And somewhere in the dark, between the stars, the great silence grows deeper, one civilization at a time. And if the filter is ahead of us, then every light we turn on, every signal we send, every way we make ourselves visible, might be pulling that trigger just a little closer. Picture a world, any world. It doesn't matter. We're orbiting a red dwarf in the Andromeda galaxy, circling a yellow sun in a cluster. We'll never name spinning in the dark between spiral arms. We'll never map. On this world beneath a sky that has never known pollution or satellites, a creature stands upright for the first time. It's not human. It will never be human. But it is in this moment something new, aware. This is how it always begins. Not with a bang, not with intention, but with a small, almost invisible threshold being crossed. A hand grasping a stone and recognizing it not just as an object, but as a tool. A voice making a sound, and understanding that the sound can mean something beyond itself. A mind looking at the patterns in nature and seeing for the first time the difference between what is and what could be. From that moment, everything accelerates. The stone becomes a blade. The blade cuts wood. The wood becomes fire. The fire transforms night into day, cold into warmth, raw into cooked. Each discovery unlocks the next faster and faster until what was once a species like any other, concerned only with food and shelter and reproduction, becomes something unprecedented, a force that can reshape its environment, that can pass knowledge across generations, that can imagine futures that don't yet exist, and then build them. On Earth, This process took millions of years. On other worlds, it might happen faster or slower, but the trajectory is always the same. Tool use leads to language. Language leads to cumulative culture. Culture leads to agriculture, which leads to cities, which leads to writing mathematics, metallurgy machinery. Each civilization, no matter how alien, must climb a similar ladder. The rungs might be different, but the direction is always up, toward greater complexity, greater power, greater control over the physical world. And with that control comes light. Not just the light of fire, though. That's where it starts. But the light of electricity humming through wires and illuminating streets that never sleep. The light of industry blast furnaces glowing red through the night. The light of cities sprawling across continents, visible from orbit as webs of brilliance against the dark. And finally, the light that leaks into space itself, radio waves carrying voices and music, and data spreading outward at the speed of light, unstoppable and eternal. This is the moment every technological civilization reaches, the moment it becomes visible, the moment it stops being a quiet chemical process confined to one small world and becomes a beacon announcing its presence to anyone or anything capable of detecting it. For us, that moment came shockingly recently. In 1901, Guglielmo Marconi sent the first radio signal across the Atlantic Ocean. It was a simple thing, just 3 dots, the letter S in Morse code, traveling through the air from Cornwall to Newfoundland. Marconi thought he was building a communication system for Earth. He didn't realize he was lighting a fire that would be visible across light years. Within decades, radio became ubiquitous. Commercial stations broadcast news and music. Military installations bounced radar pulses off the atmosphere. Television signals carried images through the air. Every transmission, no matter how mundane, radiated outward in all directions. Some of that energy bounced off the ionosphere and returned to Earth, but some of it, a small fraction, but a real fraction, escaped into space. And once in space, it never stops. There's no friction, no air resistance, nothing to slow it down or absorb it. A radio wave, once emitted, becomes a permanent part of the universe, traveling outward at the speed of light forever. Right now, the first radio transmissions from the early 20th century have formed a sphere roughly 120 light years in radius, centered on Earth. Inside that sphere are 59 star systems, within 20 light years, hundreds more, within 50 and thousands of potential planets. Think about what that means. If there's an observer on a planet 80 light years away, with technology sensitive enough to detect faint radio signals, they're listening to Earth's broadcasts from the 1940s right now. They're hearing World War II news reports, big band music, the first primitive TV transmissions. To them, Earth is a world in crisis, tearing itself apart with violence, while simultaneously exploding with technological innovation. They're seeing us not as we are, but as we were. And every year, as our expanding bubble of radio light reaches farther, more distant observers get their first glimpse of humanity. We've been shouting into the void for over a century, completely unaware of what that shout might mean. Each generation of technology has made us louder. Early radio was weak and unfocused, scattering in all directions, but quickly fading to background noise. But military radar designed to detect aircraft and missiles was powerful and directional, sending tight beams of microwave radiation that could be detected from much farther away. The Arecibo Observatory in Puerto Rico, when it was active, was one of the most powerful radio transmitters ever built. When it sent signals for planetary radar studies, it briefly made Earth the brightest radio source in the solar system, outshining even the sun at certain frequencies. We did all this without really thinking about it. Radio communication was too useful to worry about cosmic implications. We needed to talk to each other across oceans and continents. We needed to navigate planes, track weather, communicate with satellites. The fact that these signals were also escaping into space was just an afterthought, a curiosity mentioned in popular science articles, but not something anyone lost sleep over. But here's what we didn't consider. In a universe where silence might be survival, loudness is vulnerability. Every radio pulse, every radar ping, every stray signal from our satellites is a clue, a breadcrumb trail leading directly back to Earth. And unlike biological signatures, oxygen in our atmosphere, methane, from our swamps, which are passive and ambiguous, radio signals are unmistakable. They're too structured, too regular, too clearly artificial to be anything but the product of technology. To any civilization listening, our radio bubble is a message. Not the message we intended to send, but a message nonetheless. It says, someone here has mastered electromagnetism. Someone here has built complex machinery. Someone here is young, careless, and doesn't yet understand what it means to be heard. And perhaps most importantly, it says, we are here. This is where we are. This is how to find us. The sphere of our transmissions expands at the speed of light, which sounds fast until you realize how vast space actually is. It will take 4.24 years for our signals to reach Proxima Centauri, our nearest neighboring star. It will take 25,000 years to reach the cluster of stars we sent the Arecibo message to. But time is patient and space is full. Every year our bubble encompasses new star systems. Every year, new worlds enter the range where they could in principle detect us. Most of those worlds are probably lifeless. Most stars don't have planets in the habitable zone. Most planets in the habitable zone don't have life. Most worlds with life don't have intelligence. We know all this, but most is not all. And with thousands of star systems now within our radio bubble, and millions more to be encompassed in the centuries ahead, the probability that someone is listening stops being theoretical and starts being statistical. And if they're listening, what do they hear? They hear a species in its technological adolescence, broadcasting its existence with the innocent confidence of someone who's never been hurt before. They hear us talking to each other, arguing, laughing, creating art, waging war, all of it spilling out into the cosmos without filter or caution. They hear exactly the kind of noise a young civilization makes when it doesn't yet understand the rules of survival in a universe that might not be friendly. On Earth, every ecosystem has the same basic rule. Predators evolve to detect prey. The better you are at hearing, smelling, or seeing your food, the more you eat, and the more successful you are. This drives an evolutionary arms race where prey must become stealthier and predators must become more sensitive. The result over millions of years is that the most successful predators are the ones who can detect the faintest signals. If that same evolutionary logic applies on a cosmic scale, if the universe has selected for civilizations that are very, very good at detecting others, then our radio bubble isn't just visible, it's a flare, a spotlight, a dinner bell ringing in the dark. And the truly terrifying part is that we can't stop it now. Even if we went completely silent today, shut down every radio transmitter on Earth, stopped all our broadcasts and military radar and satellite communications, it wouldn't matter. The signals we've already sent are gone. They're already out there propagating through space, carrying our message, whether we want them to or not. We've already announced ourselves. We've already lit the fire. All we can do now is wait and see what comes, to investigate the light. And while we wait, we need to understand what that light might attract and what happens when a young civilization makes itself known in a universe that has rules we're only beginning to glimpse. In 2008, a Chinese science fiction writer named Liu Cixin published the second book in a trilogy that would go on to win the Hugo Award and change how many people think about the cosmos. The book was called The Dark Forest, and buried within its narrative of alien invasion and interstellar conflict was an idea so elegant and so chilling that it's haunted conversations about extraterrestrial contact ever since. Liu Cixin didn't discover some new physics or uncover hidden astronomical data. What he did was apply game theory, the mathematical study of strategic decision-making, to the question of how intelligent civilizations might behave toward each other across the vast distances of space. And the conclusion he reached was both perfectly logical and perfectly horrifying. The dark forest theory rests on just two axioms, two simple assumptions that almost anyone would agree are reasonable. The first, all life desires to survive. This isn't controversial. Survival is the most basic drive of any living thing, from bacteria to humans, to presumably any alien intelligence we might encounter. No matter how strange or advanced a civilization might be, if it exists, it wants to continue existing. The second axiom is equally straightforward. There's no way to know if other civilizations will follow this same logic, or if they might view your survival as a threat to their own. This is the problem of cosmic uncertainty. When two civilizations are separated by light years, when communication takes decades or centuries, when biological and cultural differences might be so vast that true understanding is impossible. You cannot know intentions. You cannot trust. You cannot negotiate in any meaningful sense. From these two simple axioms, the desire to survive and the impossibility of knowing others' intentions, flows a conclusion that feels almost inevitable once you see it. Liu Cixin called it the chain of suspicion. Imagine two civilizations detect each other. Call them A and B. Civilization A must now ask, is B hostile? Even if A is peaceful and means no harm, A cannot know what B intends. Maybe B is also peaceful, but maybe B views any other intelligent life as a potential threat, or as a source of resources, or simply as an obstacle to be eliminated. A doesn't know. And here's the crucial part. A knows that B faces the exact same uncertainty about A. So A thinks B doesn't know if I'm hostile. B might be afraid that I'm a threat. And if B is afraid, B might decide to attack me preemptively, just to be safe. And if I think B might attack me, then maybe I should attack B first, before they get the chance. But it gets worse. A also thinks B is probably thinking the same thing. B might attack me, not because B is actually hostile, but because B thinks I might be hostile, or because B thinks I think B might be hostile. The chain of suspicion has no end. Each level of meta-reasoning, I think you think adds another layer of paranoia, another reason to view the other with fear rather than hope. And remember, all of this is happening across distances measured in light years. If A and B are 100 light years apart, any message A sends takes 100 years to reach B, and any response takes another 100 years to return. 2 centuries for a single exchange. In that time, civilizations can rise and fall. Technology can advance beyond recognition. Entire species can evolve or go extinct. There is no possibility of real dialogue, no way to build trust through repeated interactions and proven good faith. Diplomacy, as we understand it, cannot exist across interstellar distances. The time delays are simply too vast, and in the absence of diplomacy, fear becomes the only rational response to contact. Liu Cixin took this logic one step further. He argued that in such a scenario, the safest strategy for any civilization isn't to communicate or even to wait and see. The safest strategy is to immediately destroy any other civilization you detect before they can become a threat. Strike first, strike without warning, strike from a distance, and eliminate the potential danger before it even knows you exist. This sounds monstrous. It sounds like paranoia taken to a psychotic extreme. But from a game theory perspective, it's perfectly rational. If you cannot trust, if you cannot communicate, if you cannot know whether another civilization will do the same calculation and strike first, then attacking preemptively, while morally abhorrent by human standards, is the strategy that maximizes your chances of survival. This is why Liu Cixin called it the Dark Forest. Imagine the galaxy as an enormous forest at night, impossibly vast and impossibly dark. In that forest are billions of hunters, civilizations, each one armed and afraid. They move carefully, silently, aware that any sound might give away their position. They listen constantly for others, but they never call out, never announce themselves, never light a fire, because they know the rule that governs this forest. The moment you reveal your location, the moment you make a sound, or show a light, you become a target. Someone out there, someone you can't see and don't know, will hear you, and they will shoot. Not out of malice, not out of cruelty, but out of simple survival logic. Better to eliminate a potential threat than to risk being eliminated by it. In the dark forest, every civilization is both hunter and prey. The only winning move is silence, and the only civilizations that survive long enough to spread across the galaxy are the ones that learned this lesson early, the ones that went quiet and stayed quiet, hiding in the shadows, never revealing themselves, waiting and listening, but never speaking. This would explain the Fermi paradox perfectly. The silence we hear isn't because no one's out there. It's because everyone's out there hiding from everyone else. The galaxy isn't empty. It's full of civilizations holding their breath in the dark, terrified that making a sound will bring annihilation. And if this is true, if the dark forest is the actual state of the universe, then humanity has made a catastrophic mistake. We've been shouting into that forest for over a century. We've been lighting fires, sending up flares, broadcasting our position to anyone and everyone who might be listening. We've done this with the innocent assumption that anyone out there would be friendly, or at least curious, or at worst indifferent. But in the dark forest, there's no such thing as a friendly first contact. There's only the hunter who shoots first and the prey who reveals itself too soon. And we young, naive, hopeful humanity have spent the last 100 years painting a target on our backs, completely unaware that we might be standing in the crosshairs of something old, patient, and very far away. The dark forest theory isn't just about aliens. It's about the fundamental logic of survival in a universe where trust is impossible and caution is the only adaptive strategy. It's a game theory nightmare scaled to cosmic proportions. And the most terrifying part isn't that it might be true, it's that we might be about to find out. The forest is dark. We've lit our fire, and now we must face what that light has already revealed. The signal cannot be unsent. It moves through darkness, carrying our address to eyes we cannot see. We are not the observers. We are the observed. There's a sphere expanding around Earth, right now invisible but inexorable, growing larger with every passing second. It's not made of matter or energy in any conventional sense. It's made of information, a shell of electromagnetic radiation carrying the complete, unfiltered story of human civilization, spreading outward at the speed of light into a universe we barely understand. Right now, that sphere has a radius of roughly 120 light years. Inside it are approximately 59 star systems within 20 light years of Earth, hundreds more within 50, thousands of potential planets, some orbiting in habitable zones, some perhaps harboring life, some possibly hosting intelligences far older and more sophisticated than our own. And every single one of them, if they possess the technology to listen, has heard us. This is not a metaphor. This is physics cold and precise and utterly indifferent to our intentions. When Marconi sent that first signal across the Atlantic in 1901, he didn't just revolutionize human communication. He announced our presence to the cosmos. Every radio broadcast since then, every television signal, every radar pulse, every transmission from every satellite has added to that expanding bubble layer upon layer of human noise propagating forever through the void. The early signals were crude, weak, scattered analog broadcasts that degraded quickly as they spread. By the time they reached even the nearest stars, they would be barely distinguishable from background radiation, a faint structured hiss that could be natural or could be something more. An observer would need patience and sophisticated equipment to detect them. But we didn't stay quiet for long. By the 1950s, television had exploded across the developed world. Millions of transmitters broadcasting simultaneously, filling the airwaves with everything from news reports to sitcoms to advertisements for products that haven't existed for decades. To an alien astronomer 50 light years away, Earth in the 1970s would have been lighting up like a beacon suddenly bright in radio frequencies, where previously there had been only the dim background of natural cosmic processes. And then came military radar. This was different from civilian broadcasting, more powerful, more focused, designed to bounce signals off aircraft and missiles with enough strength to detect the return echo. Military installations around the world sent pulses of microwave radiation into the sky, some of it absorbed by the atmosphere, some reflected back to ground stations, but a portion, always a portion, escaping into space. These weren't the random whispers of radio static. These were structured, rhythmic, unmistakably artificial signals. A civilization with even moderately advanced technology could detect them from hundreds of light years away and know with certainty that something intelligent had created them. There's simply no natural process that produces that kind of regularity, that kind of mathematical precision. Think about what we've actually revealed. Any observer analyzing our transmissions wouldn't just know that we exist. They'd know what we are. They could analyze the modulation patterns of our broadcasts and deduce our level of technological sophistication. They could detect the Doppler shifts caused by Earth's rotation and determine our planet's spin rate. They could measure the spread of frequencies we use and infer the basics of our atmosphere's composition. If they listened long enough, if they had the computing power to decode our analog and digital signals, they could actually watch our television shows, hear our music, intercept our communications. They'd see us at war and at peace, creating art and destroying each other, laughing and crying and struggling through existence. They wouldn't need to visit to understand us. Our transmissions would tell them everything: our biology, our psychology, our strengths, and most importantly, our weaknesses. And here's what makes this profoundly unsettling. There's a delay, but it's not a protection. A civilization, 80 light years away, is receiving our broadcasts from the 1940s right now. They're watching World War II unfold in real time from their perspective. They're seeing us split the atom and immediately weaponize it. They're watching us demonstrate both incredible technological capability and devastating moral failure simultaneously. What conclusions might they draw from that? The information bubble doesn't just carry our achievements. It carries our mistakes, our violence, our carelessness. It reveals us as a species that develops powerful technologies faster than we develop the wisdom to use them safely. It shows us as young, aggressive, unpredictable. And if the dark forest theory is correct, unpredictable is the most dangerous thing a civilization can be. But perhaps the most concerning aspect of our radio bubble isn't what we've broadcast accidentally. It's what we've sent intentionally. In 1974, scientists at the Arecibo Observatory in Puerto Rico did something unprecedented. They deliberately transmitted a message designed for alien comprehension, aimed at a globular cluster called M13, about 25,000 light years away. The Arecibo message was elegant in its simplicity. It contained the numbers 1 through 10, the atomic numbers of elements essential to life, the formulas for DNA nucleotides, a crude diagram of our DNA's double helix structure, a representation of a human being, the population of Earth, a diagram of our solar system with Earth highlighted, a representation of the Arecibo telescope itself, in 1679 binary digits chosen specifically because it's the product of two prime numbers, making the message's structure mathematically obvious. We encoded a message that said, in effect, this is what we are. This is where we are. This is how many of us there are. This is how advanced our technology is. It was an act of profound optimism, born from the assumption that any civilization advanced enough to receive and decode it would also be benevolent enough not to use that information against us. We were introducing ourselves to the cosmos the way you might introduce yourself to a new neighbor, with hope, curiosity, and the assumption of good faith. But in the dark forest, good faith gets you killed. The Arecibo message won't reach M13 for another 23,000 years, and any response wouldn't return until 48,000 years from now. In practical terms, it's unlikely to ever matter, but the message itself, the decision to send it, matters immensely because it reveals something about humanity's relationship with the unknown. We looked into the dark and chose to speak. We chose visibility over caution. We chose hope over fear. And we did it without consensus, without really considering the implications, without asking whether the entire species should consent before revealing its location to the universe. A handful of scientists made a decision that in principle affects every human being who will ever live. If there's something out there, something old and patient and not inclined toward mercy, we've told it exactly where to find us. The uncomfortable truth is that our radio bubble, accidental and intentional, represents a one-way announcement that cannot be unsent. Even if every transmitter on Earth went silent today, the signals we've already broadcast would continue outward, forever marking our presence, carrying our story, revealing our location to anyone capable of listening. We've spent over a century creating an expanding sphere of evidence that we exist and there is no technology, no physics, no way to take it back. We are already exposed, already visible, already heard by anyone within that 120 light-year sphere who has the means to detect electromagnetic radiation and the curiosity to investigate structured signals. The only question remaining is who's listening. But perhaps the listeners aren't distant. Perhaps they've been close all along, watching with patient eyes older than our species. They might already be here, not landing in parks or hovering over cities, but present in the way shadows are present, unnoticed, patient waiting. In 1973, radio astronomer John Ball proposed an idea that was both comforting and deeply unsettling. He suggested that the reason we haven't made contact with alien civilizations isn't because they don't exist, but because they're deliberately avoiding us. He called it the zoo hypothesis, and the analogy is exact. Earth might be a nature preserve, and we are the wildlife observed but never contacted left to develop naturally without interference. Imagine it from their perspective. An advanced civilization, millions or billions of years old, discovers a young species, us just beginning to figure out radio and spaceflight. They have a choice. They could reveal themselves, make contact, share knowledge, but doing so would fundamentally alter our development. Our religions would collapse or transform. Our sense of uniqueness, of cosmic importance would shatter. Our entire trajectory as a species would be irrevocably changed by the knowledge that we are not alone and not the most advanced. So, instead they watch, they study, they observe from a distance that makes interference impossible and discovery unlikely. Like biologists studying an uncontacted tribe, or zoologists watching animals in their natural habitat, they maintain strict non-intervention, not out of cruelty, but out of respect, or perhaps out of caution, waiting to see if we'll survive our own adolescence. before deciding whether we're worth engaging. This would explain the Great Silence perfectly. Not absence but policy, not emptiness but restraint. The galaxy could be full of civilizations, all of them aware of each other, all operating under a shared agreement. Leave developing species alone until they're ready, or until they're not, and they destroy themselves, solving the problem of what to do with them. But there's another possibility, more immediate and more unsettling. Perhaps they're not just watching from afar. Perhaps they're watching from very, very close. In 1960, mathematician John von Neumann proposed a concept that would revolutionize thinking about space exploration. He described what are now called von Neumann probes, self-replicating machines that could explore the galaxy autonomously. The idea is elegant. You build one probe, send it to a nearby star system, and program it to use local resources to build copies of itself. Those copies spread to other systems, each one building more copies. In this way, a single civilization could explore the entire galaxy within a few million years, a geological eye blink in cosmic time. If such probes exist, if even one ancient civilization built and deployed them billions of years ago, they should be everywhere by now, including here, including in our solar system. They wouldn't be large. They wouldn't need to be. A probe the size of a car, or even smaller, would have more than enough capability to observe Earth, analyze our transmissions, catalog our development. It could hide in the asteroid belt, indistinguishable from countless other rocks. It could orbit in the outer solar system, beyond Neptune, where we've barely looked. It could even be on the moon, sitting in a crater on the far side, watching Earth with patient instruments that never blink. We wouldn't see it unless it wanted to be seen. Our telescopes are designed to find planets and stars, not small artificial objects. Our deep space tracking is focused on our own satellites and occasional asteroids that might pose a collision threat. A sophisticated probe designed for stealth could observe us indefinitely without detection, and maybe one already has. In 2017, astronomers discovered something that shouldn't have been there, an object reddish in color and oddly elongated, tumbling through our solar system on a hyperbolic trajectory, meaning it came from interstellar space and was just passing through. They named it Oumuamua Hawaiian for scout or messenger from afar arriving first. Oumuamua was strange from the start. Its shape was unusual, 10 times longer than it was wide, like a cosmic cigar or pancake. Its surface reflected light in ways that suggested metal or extremely dense ice, and most puzzling, as it rounded the sun and began to leave it, accelerated slightly, pushed by a force that wasn't gravitational. Some proposed outgassing from icy material, but Oumuamua showed no comet tail, no visible emissions. It just accelerated. Most scientists concluded it was a natural object, perhaps a shard of a planet broken apart in another star system. But a few, including prominent astronomers, asked uncomfortable questions. What if it wasn't natural? What if the acceleration was from adjusting course? What if Oumuamua was exactly what its name suggested, a scout checking on the loud young civilization that had suddenly started broadcasting into the void? We'll never know. Oumuamua is gone now, accelerating out of the solar system, headed back into the dark between stars where it came from. We had only weeks to study it, and our instruments weren't prepared for something so unexpected. It's out of range now, invisible even to our best telescopes, carrying whatever secrets it holds away from us forever. But here's the thing, Oumuamua might not have been unique. It might just have been the first interstellar object we noticed. Now that we know what to look for, astronomers are finding more, including Borisov, a clear interstellar comet discovered in 2019. The space between stars might not be as empty as we thought. Objects drift between solar systems, some natural, some perhaps not. If silent probes do exist, if watchers have been placed throughout the galaxy to monitor developing civilizations, then Earth would be an obvious candidate for observation. We're a rocky planet in the habitable zone of a stable star. We have liquid water, complex life, and now, very recently, technology. From a surveillance standpoint, we'd be exactly the kind of world worth keeping an eye on. And what would those watchers have seen? They'd have watched us evolve from stone tools to nuclear weapons in the blink of an eye, cosmically speaking. They'd have seen our population explode from millions to billions. They'd have watched our lights spread across the continents, our satellites multiply in orbit, our radio signals begin their outward journey. They'd have complete documentation of our development, a perfect record of everything we've done, every mistake we've made, every choice that brought us to this moment. They would know if we're likely to survive. They would have seen this pattern before the rapid technological acceleration, the environmental stress, the weapons capable of self-annihilation. They'd know with statistical confidence whether we're about to pass through the great filter or become another data point in the catalog of civilizations that didn't make it, and if they've concluded we're not going to survive. If their models predict our collapse or self-destruction in the next century or two, then there's no reason to reveal themselves. No point in making contact with a species that's already on its way out. Better to simply watch, document, and wait for the inevitable silence. Or perhaps, and this is darker still, they're not waiting. Perhaps they're actively ensuring certain outcomes, not through invasion or violence, but through something more subtle. A nudge here, a technological hint there, a carefully placed idea that accelerates us toward the filter rather than away from it. After all, if the dark forest is real, if the galaxy operates on rules of paranoid survival, then the safest approach to a rising civilization isn't to destroy it overtly. It's to let it destroy itself, or to help that process along while maintaining perfect deniability. We imagine first contact as a moment of revelation, ships landing beings, emerging knowledge shared. But what if first contact already happened? What if it happens quietly, constantly through probes that have been here longer than our species, watching us with the patient indifference of scientists observing lab subjects? What if every major turning point in human history, the sudden leap to agriculture, the simultaneous development of writing in multiple cultures, the unexplained technological booms, what if some of those weren't entirely our doing? The zoo hypothesis offers a gentler interpretation. We're being protected, preserved, given space to grow. But protection and imprisonment can look very similar from inside the cage. And if we're in a zoo, we have to ask what happens when the zookeepers decide we're no longer interesting, or when they conclude were too dangerous to keep around. The Watchers, if they exist, are not our friends. They might not be our enemies either. They might be something worse, neutral observers recording our story with neither hope nor concern, waiting to see how this particular experiment in consciousness ends. And when it does end, whether in transcendence or extinction, they'll simply update their records and move on to the next young civilization, making noise in the dark. We look up at the stars and feel alone. But the truly unsettling possibility is that we've never been alone at all. That something has been watching since before we knew how to watch back. That our entire history as a technological species has unfolded under observation every moment, cataloged every choice, noted every step toward survival or destruction, carefully documented by minds we cannot comprehend. The silence of the cosmos might not be absence. It might be the sound of someone holding very still, watching very carefully, waiting to see what we do next. And somewhere, perhaps very far, perhaps unsettlingly close, they're taking notes. If Watchers exist, they possess something we don't, the means to end us from a distance we cannot even imagine. In the universe, physics itself is the ultimate weapon, and it requires no hatred, only mathematics. We imagine interstellar war as something from movies, fleets of ships, exchanging laser fire, dramatic explosions, heroic last stands. But real cosmic violence would look nothing like that. It would be cold, efficient, and absolutely unstoppable. A civilization advanced enough to wage war across light years wouldn't need exotic technologies or science fiction weapons. They'd only need to understand physics and the willingness to use it. Consider the simplest weapon imaginable: a rock. Not a sophisticated missile, not a guided projectile, just a dense piece of matter, now accelerated to a significant fraction of light speed. Doesn't matter how you do it: railgun laser, propulsion, gravity assist from multiple stars. The method is irrelevant. What matters is the result. At 90% the speed of light, a rock the size of a refrigerator carries kinetic energy equivalent to hundreds of nuclear weapons. When it strikes a planet, it doesn't explode in the conventional sense. It simply transfers all that momentum and energy in a fraction of a second. The impact site doesn't just vaporize. It ceases to exist in any meaningful way. The shockwave races outward, faster than sound can travel. The heat flash ignites the atmosphere. The crust fractures like dropped glass. And here's the beautiful, terrible elegance of this weapon. It's completely unstoppable once launched. There's no defense. You can't shoot it down by the time you detect it. It's already hit you. Lightspeed travel means lightspeed information, which means you see it and die in the same instant. No warning, no evacuation, no last-minute miracle. Just existence, one moment, and the next silence. This is called a relativistic kill vehicle, and it's not science fiction, it's physics. Any civilization capable of accelerating objects to near light speed, something we're already theorizing about with Project Starshot, and similar concepts, possesses the capability to sterilize planets from across the galaxy. They wouldn't need to visit, wouldn't need to risk their own lives. They could fire from 1,000 light years away and simply wait, confident that centuries or millennia in the future, the threat would be eliminated. But kinetic weapons are crude, obvious. They leave evidence. If you wanted to be subtle, If you wanted your attack to look like a natural disaster or cosmic bad luck, you'd use something else. Directed energy, for instance. Imagine focusing the light of a star. Not the entire output, that would be impossible and unnecessary, but even a tiny fraction concentrated into a beam tight enough to maintain coherence across light years. The technology would be a megastructure, something like a Dyson swarm, millions of solar collectors and mirrors working in perfect coordination. Point that beam at a planet and simply turn it on. From the target's perspective, it would start with strange atmospheric phenomena. The sky brightening on one side, unusual heating patterns, maybe a few days or hours to realize something's wrong, nowhere near enough time to do anything about it. Then the beam reaches full intensity. The atmosphere ignites. Oceans begin to boil. The surface temperature rises hundreds of degrees within minutes. Within an hour, the planet is uninhabitable. Within a day, it's sterilized completely. And the beautiful horror of this weapon, to any distant observer, it would look entirely natural. A solar flare from their own sun, perhaps. A gamma ray burst from a distant supernova that just happened to be aimed their way. Tragic cosmic coincidence. No evidence of attack. No way to trace it back to its source. The perfect crime written in physics and executed with light itself. But perhaps even energy weapons are too noticeable, too likely to leave traces that other civilizations might detect and learn from. If you wanted to eliminate a threat with absolute deniability, you'd go smaller, much smaller. Nanotechnology offers possibilities that would have seemed like magic to earlier generations. Self-replicating machines, molecular in scale, programmed with a single directive, convert matter into copies of yourself. Released on a planet, they wouldn't announce themselves. They'd simply begin replicating, using whatever raw materials they encountered: soil water, organic matter, eventually metals and minerals. The first few generations would be invisible. By the time anyone noticed strange patterns in crops, unusual mineral depletion, inexplicable equipment failures, it would already be too late. The nanomachines would have reached exponential growth, doubling every few hours or days, spreading across the planet like a gray tide. Within weeks, the biosphere would be converted. Within months, the planet itself would be transformed into nothing but trillions upon trillions of identical mindless machines, having consumed everything that once lived or could sustain life. This is the gray goose scenario, and it requires no malice, no ongoing control, no presence. You design the machine, release it from orbit, and leave. By the time you're back in your home system, light years away, the job is done. And to anyone investigating the dead world later, it would appear to be a technological accident, a civilization that developed nanotechnology and lost control of it. Not murder, just unfortunate, or consider biological weapons, but scaled to cosmic levels. If you've studied a target civilization long enough, listen to their transmissions, analyze their chemistry, perhaps captured some biological samples from space debris or ancient probes they sent out, you could engineer a pathogen specifically designed for them. Not a crude virus, not something they could fight with vaccines or immune responses. Something elegant, something that targets their specific genetic structure, their particular biochemistry, something that spreads silently, incubates long enough to infect the majority of the population before anyone realizes they're sick, and then activates with lethal efficiency. 90% mortality rate, maybe higher, released at multiple points across their world, simultaneously easy enough with a few small stealthy probes. Within a generation, the civilization collapses, infrastructure fails, knowledge is lost. The survivors, if any, are scattered and primitive. They might not even remember what they once were, and centuries later, when another species discovers their world, they'd find ruins and scattered populations, victims of a plague that no one could trace or explain. The planet survives, the biosphere largely intact, only the intelligent species removed with a surgical precision, and absolutely no evidence pointing to the actual cause. Natural pandemic. These things happen, tragic but not uncommon in the cosmos. What makes all these weapons especially terrifying is their shared characteristic distance and anonymity. In terrestrial warfare, you have to be present. You risk counterattack. You leave evidence. But in cosmic terms, where everything happens across light years and centuries, the attacker has every advantage. Launch a relativistic projectile, and by the time it hits, you could be dead of old age, or your civilization could have moved to another star system entirely. Use a directed energy weapon, and the light announcing the attack travels at the same speed as the weapon itself, meaning the target sees the beam only when it's already burning them. Release self-replicating nanomachines or engineered pathogens, and you're gone before they even activate. There's no retaliation because the victim doesn't know who attacked them. There might not even be proof an attack occurred at all, just the sudden, unexplainable extinction of a species that was thriving one moment and gone the next. In a cosmic investigation, such events would be marked down as natural causes, or technological mishap, or simply unknown. The truth would be hidden, not by deception, but by the fundamental nature of space and time. This is why the dark forest is so chilling. It's not about aliens being evil or humans being special. It's about the logic of survival when trust is impossible and anonymity is guaranteed. If you can eliminate a potential threat with zero risk to yourself, zero chance of being caught, and methods that look natural or accidental, then the only question becomes, why wouldn't you? And perhaps that's what happened to all the others. Perhaps the galaxy was once louder, filled with young civilizations broadcasting their presence like we are. Perhaps some of them even sent out messages, hopeful greetings cast into the void. And perhaps one by one they fell silent, not through cosmic accidents or self-destruction, but through the calculated actions of others who saw light in the forest and decided it was safer to extinguish it. The weapons exist. The physics allows them. The logic justifies them. And somewhere in the dark, patient and unseen civilizations, old enough to have perfected these methods, might be watching us, listening to our broadcasts, noting our coordinates, waiting to see if we're a threat worth eliminating, or simply deciding that any new voice in the forest is one voice too many. And if such weapons have been used, the evidence would look exactly like what we've been finding worlds that should be alive but aren't. Perhaps we've already found the crime scenes. We just haven't recognized them for what they are. When we discover exoplanets, we celebrate each finding as a triumph of human ingenuity, a step closer to finding life beyond Earth. We catalog their sizes, their orbits, their distances from their stars. We look for water, for atmospheres, for chemical signatures that hint at habitability. And sometimes, more often than feels comfortable, we find planets that make no sense, worlds that should have atmospheres but don't, planets in perfect habitable zones, the right size, the right temperature, orbiting stable stars, yet completely barren, rocky surfaces exposed to space, stripped naked by some process we can't quite explain. We have theories, of course: solar wind, magnetic field loss, giant impacts, perfectly reasonable, natural explanations. But natural explanations can also be convenient lies we tell ourselves because the alternative, that these worlds were deliberately sterilized, is too disturbing to consider seriously. Take Mars. We've known for decades that Mars once had water, lots of it. Evidence is everywhere: ancient riverbeds carved into stone minerals that only form in the presence of liquid water polar ice caps, and most tantalizingly recent, discoveries of liquid water still flowing beneath the surface in certain locations. The Mars Reconnaissance Orbiter has sent back images of what look unmistakably like dried up ocean basins, deltas where rivers once fed into vast bodies of water. Mars was, for a brief period in its history, potentially habitable, warm enough for liquid water, thick enough atmosphere for weather systems, perhaps even life, simple microbial, but life nonetheless. And then something happened. The atmosphere thinned, the water evaporated or froze or sank into the regolith. The surface became the cold, radiation-blasted desert we see today. The official explanation is magnetic field loss. Mars's core cooled, its magnetic field collapsed, and without that protection, solar wind stripped away the atmosphere over millions of years. Slow, natural, inevitable. Nothing suspicious about it, except Mars lost its magnetic field suspiciously quickly in geological terms, and the atmospheric loss was more catastrophic than models predict it should have been. And there are isotopic ratios in Martian soil, particularly in certain regions, that look oddly similar to what you'd expect from intense energetic events. Not quite nuclear detonation signatures, but close enough to make you wonder, what if Mars wasn't a natural failure? What if it was an elimination? A young biosphere just beginning to show promise, noticed by something that decided it was safer to scour it clean than to wait and see what might evolve there. A few relativistic impacts to crack the crust, a directed energy beam to boil off the oceans, and then silence a dead world that looks to our instruments like nothing more than a planet that got unlucky with geology. We'd never know the difference. Venus presents an even stranger case. It's often called Earth's twin, similar size, similar composition, similar distance from the Sun. Early in solar system history, Venus might have been habitable. Some models suggest it could have had oceans for 2 billion years or more. 2 billion years. Enough time for life to begin, to diversify, possibly even to become complex. Now, Venus is hell incarnate. Surface temperature hot enough to melt lead. Atmospheric pressure 90 times Earth's. Clouds of sulfuric acid. A greenhouse effect so extreme, it's turned the planet into an oven that would sterilize anything we could imagine. The standard explanation: runaway greenhouse effect. Venus is closer to the Sun, received slightly more solar radiation water vapor, accumulated in the atmosphere, trapped more heat, released more water vapor, in a feedback loop that couldn't be stopped. Eventually, the oceans boiled away, completely the carbon that had been locked in rocks, released into the atmosphere, and the planet transformed into the hostile world we see today. Natural process. No intervention required. But here's what's odd. The transformation happened relatively quickly, geologically speaking, and it happened completely. There are no pockets of survivability, no regions where the old climate persists, no refugees where life could have retreated. The sterilization was absolute and uniform, almost as if something ensured there would be no survivors, no remnants, no possibility of recovery. And then there are the exoplanets we found that defy easy explanation. HD 189733b, a gas giant orbiting close to its star, where rain falls sideways at 7 times the speed of sound, and temperatures reach thousands of degrees. Kelt 9b, so hot, its atmosphere is literally evaporating away into space. Kepler 70b, orbiting so close to its star that its surface is a molten ocean of vaporized rock. These we can explain through natural formation and orbital mechanics. But what about the rocky planets we've found in habitable zones with no atmospheres? What about the worlds that should by all our models be teeming with at least microbial life, but show no biomarkers whatsoever? When we analyze their light spectra, we call them failed Earths and move on. But what if they didn't fail? What if they succeeded briefly and then something noticed? There's a particular subset of exoplanets that trouble astronomers but rarely make headlines. Planets with unusual isotopic abundances in their atmospheres, ratios of elements that don't match what we'd expect from natural, stellar, and geological processes, excess of certain heavy elements, abnormal distributions of radioactive isotopes, chemical signatures that could be explained by natural means, but also could be explained by other means. If you wanted to sterilize a planet and make it look natural, you'd be careful about the method. Too obvious, like orbital bombardment, leaving impact craters everywhere, and you create evidence. But if you used methods that mimic natural disasters, that create signatures similar to volcanic eruptions or asteroid impacts or stellar events, then any investigation thousands or millions of years later would find exactly what you wanted them to find: a dead world with a plausible natural explanation for its death. And perhaps that's what we're seeing when we survey exoplanets. Not a cosmos where life is rare, but a cosmos where life is regularly cold, where the galaxy is full, absolutely full, of habitable worlds, but empty of inhabitants, because something somewhere has been maintaining that emptiness for a very long time. This would explain another mystery, the apparent age gap. When we look at the galaxy, we find stars of all ages, from newborns to ancients, billions of years older than our sun. We find planets around stars of every generation. By rights, we should see evidence of civilizations at all stages of development, some younger than us, some our age, many far, far older. The galaxy should look lived in, messy, full of the accumulated artifacts of billions of years of intelligent activity. Instead, it looks pristine, untouched, as if someone's been cleaning up behind everyone else, removing the evidence, maintaining a carefully curated emptiness. We're like detectives walking through a house where everything's been wiped down, vacuumed, sanitized. The house is nice, well built, should have people living in it, but it's empty, and it's too empty, the kind of empty that takes effort to maintain. And somewhere in the back of your mind, you start to wonder, are we walking through a crime scene? The ghost planets might be tombstones, each one a marker for a civilization that revealed itself too early, that made too much noise, that drew the wrong kind of attention. Mars could have had microbes. Venus could have had oceans. That Earth-like world, 40 light years away, with no atmosphere, could have had forests once. And maybe they all had one thing in common. They showed signs of life at the wrong time, in view of the wrong observers in a galaxy where being noticed is the last mistake you ever make. We look at these dead worlds and see failure, natural disaster, cosmic bad luck. But perhaps we should be seeing them for what they really are: warnings, evidence that the universe is not a safe place for life to announce itself, proof that silence isn't paranoia, it's survival. And somewhere among the thousands of exoplanets we've discovered, cataloged, and dismissed as lifeless, there might be dozens that once sang with voices like ours, civilizations that looked up at their stars and asked the same questions we're asking. Who sent out signals? Who hoped for contact? Who learned too late what that hope costs? But the greatest danger might not come from receiving a message. It might come from trying to decide what to do with one. If we ever receive a signal from the stars, it will be the best and worst moment in human history. Imagine it's a Tuesday. Unremarkable weather. People going to work, checking their phones, complaining about traffic. And then, at a radio observatory, somewhere, let's say, Greenbank, or Parks, or one of the new facilities in South Africa, a computer algorithm flags something unusual, a pattern in the noise, not random, not natural, too regular, too structured, too mathematical to be anything but artificial. At first there's doubt, a glitch probably, interference from a satellite maybe. These false alarms happen regularly. Excited graduate students thinking they've found aliens, only to discover it's someone's microwave oven or a passing airplane's radar. So they check, they verify, they point other telescopes at the same coordinates, and the signal is still there, still structured, still impossible to explain away. Within hours, the news leaks. Within days, it's confirmed. Within weeks, the entire world knows we are not alone. Somewhere out there, someone else built transmitters, learned mathematics, and decided to speak. It would be the most transformative moment in human history. Every religion would need to be reconsidered. Every philosophy would need to be updated. Our entire understanding of our place in the cosmos would shift fundamentally and irrevocably. We'd throw parties in the streets. We'd weep with joy. We'd feel for perhaps the first time, as a species truly connected to something larger than ourselves. And then slowly, like cold water rising around your ankles, the fear would set in. Because in a universe operating under dark forest logic, any civilization that breaks the silence has made a choice. And that choice is deeply, profoundly suspicious. Think about it. If the dark forest is real, if silence truly is survival, then every advanced civilization would know this. They'd know that broadcasting your location is dangerous. They'd know that making yourself visible risks bringing down hunters you can't see or defend against. They'd know that the safest strategy is to go quiet and stay quiet forever. So, if someone is transmitting loudly enough for us to detect them across light years, they're either option 1, naive, as young and foolish as we are, not yet understanding the rules of cosmic survival, in which case they're already doomed, probably already dead by the time their signal reaches us, eliminated by someone who heard them first. Contacting them won't matter. They're ghosts, echoes of a civilization that revealed itself and paid the price. Option 2, powerful, so technologically advanced, so militarily dominant, that they don't fear being found. They can broadcast openly because they're apex predators. Nothing in their region of the galaxy poses a threat to them. If this is true, then they're not reaching out for friendship. Apex predators don't make friends with lesser species. They either ignore them or consume them. And if they've noticed us, if they're actually directing their transmission our way, it means they want something: resources, territory, or simply to eliminate potential future competition. Option 3, a trap. The signal is bait. It's designed to do exactly what it's doing, to provoke a response to make naive civilizations like ours reveal their locations by answering back. It's a hunter's call echoing through the forest, meant to make prey species give away their positions. The beings who sent it aren't looking for friends. They're looking for targets. None of these scenarios are good. Not one offers a happy outcome for humanity. And yet, the moment we detect that signal, we'll face the most consequential decision our species has ever confronted. Do we respond? Imagine the debate that would follow. It would split humanity in ways that make our current divisions look trivial. One side would argue passionately, desperately, that we must respond. This is first contact. This is the answer to our oldest question. We must not let fear stop us from reaching out, from joining the cosmic community, from taking our place among the stars. They'd say, yes, there's risk, but there's risk in everything worth doing. Our entire history is built on people who dared to explore, to reach beyond what was safe. If we let fear guide us, we're not worthy of joining whatever's out there. Besides, if they meant us harm, wouldn't they have already acted? They're advanced enough to send signals. Surely they're advanced enough to have found us already, if they were looking. The other side would counter cautiously, but with iron certainty, that responding would be suicide. They'd point to the dark forest logic. They'd note that just because we've detected one transmission doesn't mean others aren't listening silently. They'd argue that the moment we respond, we become visible to everyone in range, not just the civilization that sent the signal. They'd say, we don't know their intentions. We can't know. And in the absence of certainty, when the stakes are the potential extinction of our entire species, caution isn't cowardice, it's wisdom. We've spent 100 years accidentally broadcasting. Maybe we've been lucky so far, but deliberately responding, making ourselves even more visible, that's not bravery. That's recklessness. And here's the nightmare. There would be no way to achieve consensus. No single authority could make this decision for everyone. If the UN said, don't respond, what stops an individual nation from doing it anyway? If world governments agreed to silence, what stops a rogue scientist, a billionaire with a private transmitter, or a fringe group convinced they're doing humanity's will? All it takes is one person anywhere on Earth with access to a powerful enough transmitter to reply on behalf of the entire species. And once that signal is sent, it doesn't matter that most humans disagreed. It doesn't matter that it wasn't official or sanctioned or approved. The signal is out there, carrying our response, our location, our existence. We cannot unsend it. We cannot take it back. We cannot say, that wasn't our real answer. Please disregard. The paradox deepens when you consider timing. If we receive a signal from, say, 500 light years away, that signal left its source 500 years ago. The civilization that sent it might not even exist anymore. They could have destroyed themselves, been destroyed by others, or transcended into something we wouldn't recognize. We'd be responding to ghosts, shouting into a void that might already be empty. And even if they do still exist, even if they receive our response, it won't arrive for another 500 years. Any reply to our reply would take 500 more years. We're not having a conversation. We're exchanging messages across millennia, each transmission a time capsule sent to a future neither side can predict or control. In that span of time, entire civilizations can rise and fall. Our response, optimistic and hopeful, when sent in 2024, might reach them in 2524, when humanity is extinct, transformed, or so changed that our ancestors' words are meaningless. Their reply sent in 2524 would arrive in 3024, received by beings who might not even remember why the original message was sent. This is the fundamental problem of interstellar communication. The physics of light speed, combined with the fragility of civilizations, makes genuine dialogue impossible. At best, we're leaving notes for strangers in bottles cast into an ocean of time. And the truly cruel irony, the message itself might be the danger. Not what it says, but what it is proof that someone out there doesn't follow the rules, doesn't understand that silence is survival, doesn't know or doesn't care about the dark forest. If other civilizations are listening, and in the dark forest everyone is always listening, then they hear that signal too, and they learn two things. One, someone at those coordinates is careless enough to broadcast. Two, someone at Earth's coordinates is foolish enough to respond. Two targets, marked both now, visible both now known to every hunter in range. The original broadcaster and the naive responders, both announcing themselves to a cosmos that rewards neither honesty nor hope. Perhaps that's the real paradox of contact. The message from the stars that we've dreamed about, that we've listened for with such hope and longing, might not be an invitation to join the cosmic community. It might be a test, one final filter, separating the species wise enough to recognize danger from those too optimistic to survive. And if we respond, if we choose hope over caution, we might finally get an answer to Fermi's question. Not, where is everybody? But why is everybody silent? And by the time we understand the answer, it will be far, far too late. We stand at the threshold now between what we've done and what we must choose. The question is no longer whether others exist, but who we become in their silence. We hold the pen that writes our ending. Every choice now matters. Every silence speaks. In the cosmos, distance doesn't protect. It only delays the inevitable. We comfort ourselves with the vastness of space. 4 light years to the nearest star, tens of thousands of light years across the galaxy, millions to the next galaxy, These distances feel like insulation, like moats around castles, keeping danger away through sheer incomprehensible scale. But distance is an illusion of safety. It's not a barrier, it's just time, and time, in the universe's accounting, means nothing. Consider Proxima Centauri, our closest stellar neighbor, at 424 light-years away. If we sent a message today, "Hello, we exist, we'd like to talk," it would arrive in 2028. Any response would return in 2032, 8.5 years. For a single exchange of greetings, a conversation at that distance isn't a conversation at all. It's leaving voicemails across the void, each message received by people who've aged, changed, possibly died since the previous one was sent. Real diplomacy requires dialogue, negotiation, the ability to clarify misunderstandings, to read tone and intention, to adjust your position based on feedback. "I didn't mean it that way," or "let me explain what I meant," or "we can compromise." These phrases that make peace possible on Earth become meaningless when every exchange takes years or decades. You can't negotiate a treaty when each proposal and counterproposal is separated by generations. You can't build trust when you're talking to the grandchildren of the people who first contacted you, trying to honor agreements made by ancestors they never knew. You can't establish mutual understanding when the civilization that responds might be fundamentally different from the one that first reached out. At 100 light-years, well within our radio bubble, a misunderstanding could take 2 centuries to correct. "We come in peace" might be interpreted as "we come to take pieces." By the time you clarify, by the time you say, "No, wait, that's not what we meant," the other side has already decided you're a threat. They've already calculated that waiting another 100 years for your explanation is less safe than eliminating you now. And here's where it gets worse. At these distances, there is no such thing as a warning shot. There's no way to demonstrate strength without committing to destruction. On Earth, nations can rattle sabers, show military strength, make threats without following through. It's theater designed to avoid actual conflict by making potential costs clear. But across light years, demonstration and annihilation are the same thing. If you fire a relativistic weapon, it takes decades or centuries to arrive. You can't call it back. You can't say, "That was just to scare you." By the time it hits your intentions when you launched it, are irrelevant. The target is gone, and if you fired as a threat, meaning to miss, you've just revealed your location, your hostile intent, and your willingness to use such weapons, giving every other observer in range reason to fear and target you. Distance makes every action irreversible, every message final, every decision absolute. But here's the cruel paradox. While distance makes friendship impossible, it makes violence efficient. A relativistic kill vehicle, launched from 50 light-years away, arrives before any news of the launch could reach you. The attack and the warning travel at the same speed. You see the weapon and die. In the same instant, there's no defense because there's no warning. The distance that should protect you becomes the mechanism of your destruction. Think about what this means for strategy. On Earth, if you launch missiles, the other side's satellites detect the launch radar tracks the trajectory, and they have minutes, terrible, precious minutes, to respond. Maybe they shoot down the missiles. Maybe they launch their own in retaliation. Maybe in those final moments, someone picks up a phone and stops the madness. But in cosmic warfare, there are no final moments, no phone calls, no last-minute diplomacy. You simply cease to exist, killed by a decision made when your grandparents were children, by a civilization that might not even remember why they fired at you. And distance means that civilizations are frozen in time to each other. If we observe a planet 100 light years away and see signs of industrial civilization pollution in their atmosphere heat signatures from cities, we're seeing them as they were a century ago. They might be far more advanced now, or extinct, or transformed into something we wouldn't recognize. We're making decisions about ghosts acting on information that's obsolete before we even receive it. This temporal disconnect poisons every interaction. Imagine detecting a transmission from 200 light years away. It contains mathematical proofs, scientific data, perhaps even cultural information. Friendly, right? An exchange of knowledge. But that transmission is 200 years old. The civilization that sent it might have experienced a technological singularity, might have uploaded themselves into machines, might have expanded aggressively, and now control dozens of star systems. The friendly scientists who sent that message might be long dead, replaced by an empire that views lesser species as resources or threats. Do you respond to the message? Are you responding to who they were, or gambling on who they might be now? And will your response reach the same civilization or something that's consumed and replaced them? Distance turns every communication into archaeology. We're not talking to the living, we're talking to the dead, to echoes, to historical artifacts. And they're doing the same with us. The Earth that someone 80 light years away is observing right now is the Earth of 1944, locked in global war, having just demonstrated our ability and willingness to slaughter each other by the millions. What judgments might they make about us based on that snapshot? What decisions? But the cruelest aspect of distance is that it's not actually a barrier to the one thing that matters: destruction. Yes, it makes conversation impossible. Yes, it makes friendship implausible. But it doesn't stop violence. It just slows it down to a time scale where civilizations can be exterminated before they even know they've been targeted. A civilization 500 light years away could have decided we're a threat. In the year 1524, they could have launched relativistic projectiles then. Those weapons could be in flight right now, crossing the void at 90% of light speed, aimed at Earth with perfect precision. They'll arrive in 2080 or 2100 or 2150 dates that to them, when they launched, were the distant future. Dates that to us are close enough to matter, and we would have no idea, no way to detect them until they're already here. No warning, no negotiation, no chance to plead our case or prove we're not a threat. Just sudden absolute annihilation delivered by a decision made centuries ago by a civilization that might not even exist anymore. This is what distance really means in the dark forest. Not safety, but blindness. Not protection, but helplessness. We're shooting at ghosts and being shot by ghosts, all of us firing into a past that no longer exists, hoping to hit a future we can't predict. Every message we send travels through time as much as space, arriving in a universe that has moved on, speaking to people who are gone, making promises and threats that become meaningless in the centuries they take to deliver. We're having a conversation with delay, so extreme it ceases to be conversation and becomes something else, a sequence of soliloquies spoken into darkness, each speaker hoping against hope that someone sometime somehow will hear and understand and care. But hope doesn't travel at the speed of light. Fear does. And in a universe where distance makes trust impossible and misunderstanding fatal, fear is the only message that arrives intact. The light years between stars don't separate us from danger. They separate us from the knowledge that danger is coming until the very instant it arrives and ends everything we are. Distance is not our shield, it's our blindfold. But perhaps our greatest threat isn't light years away. Perhaps it's already here, written into our own nature. The enemy might not be in the stars. It might be staring back at us from the mirror. Every conversation about the dark forest, about alien civilizations and cosmic dangers, eventually circles back to the same uncomfortable truth. Maybe the silence of the universe isn't about others at all. Maybe it's about a test that almost no one passes. Maybe the great filter isn't some external force or cosmic predator. Maybe it's internal, built into the very nature of what it means to become an advanced technological civilization. And maybe we're living through it right now. Consider the timeline, from the first use of fire to the development of agriculture, roughly 400,000 years. From agriculture to the Industrial Revolution, about 10,000 years. From the Industrial Revolution to splitting the atom, 150 years. From the atomic bomb to artificial intelligence, 80 years. Each leap takes less time. Each threshold is crossed faster. The acceleration is exponential, relentless, and we're riding it without brakes or steering. In 1945, we created a weapon that could destroy a city. Today we have enough nuclear weapons to destroy human civilization several times over. Not damage it, destroy it. End it. Turn our world into a radioactive wasteland where nothing larger than bacteria could survive. And the terrifying part isn't that we built these weapons. It's how close we've come, repeatedly, to using them. Cuban Missile Crisis. 1962, the world came within a single human decision. A Soviet submarine captain named Vasily Arkhipov refusing to authorize a nuclear torpedo of World War III. One man's judgment stopped the end of the world. One person. One moment. That's how close the margin is. 1983, Stanislav Petrov, Soviet early warning systems detected incoming American missiles. Protocol demanded immediate retaliation. Petrov, suspecting a malfunction, disobeyed orders and didn't report the alert to his superiors. He was right, it was a false alarm. But if he'd followed procedure, if he'd been slightly more cautious or trusting of his instruments, the missiles would have launched. Civilization would have ended because of a computer glitch. These aren't ancient history. These are within living memory. And they're not isolated incidents. They're examples from a long list of near misses, accidents, false alarms, and moments when the world balanced on a knife's edge because humans had built weapons we barely understood and control systems we couldn't fully trust. And here's the horrifying part: every year, those weapons get easier to make, harder to control, and more widely distributed. In 1945, only America had the atomic bomb. By 1949, the Soviet Union had it. By the 1960s, Britain, France, and China. Today, 9 nations openly possess nuclear weapons. Several others could develop them within months, and the knowledge to build them is no longer secret. It's available in university textbooks and online documents. We keep saying, no more nations will get the bomb, and we keep being wrong. The genie doesn't go back in the bottle. The knowledge doesn't disappear. Every generation, the technology becomes more accessible, the materials easier to acquire, the barriers to entry lower. Eventually, maybe not this decade, maybe not this century, but eventually, a weapon capable of ending civilization will be within reach of not just nations, but organizations, groups, individuals. And it only takes one group convinced they're doing the right thing, one person with nothing left to lose, one miscalculation, one accident, one moment of rage or madness or absolute certainty that destruction is justified. That's all it takes to trigger a cascade that ends everything. But nuclear weapons are the obvious threat, the one we see coming. There are others more subtle, perhaps even more dangerous. Climate change isn't sudden like nuclear war. It's gradual, which makes it paradoxically harder to address. There's no moment when someone pushes a button and the world ends. Instead, temperatures rise by fractions of degrees each year. Ice melts, sea levels rise, weather patterns shift, each year slightly worse than the last, but never quite catastrophic enough to force complete societal transformation. We're like frogs in slowly heating water, each increment tolerable enough that we adjust rather than jump. Except we're running out of room to adjust. The feedback loops are beginning permafrost, melting and releasing methane, which causes more warming, which melts more permafrost. Amazon rainforest turning from carbon sink to carbon source. Coral reefs dying. Ice sheets destabilizing. The models keep being wrong, not because they're poorly made, but because they're conservative. They underestimate the speed and severity of changes, because scientists are trained to be cautious. So each year the reality outpaces the projections, and each year we discover new tipping points we didn't know existed. And each year the window for preventing catastrophic change gets smaller. And unlike nuclear war, which requires deliberate action, climate catastrophe requires only inaction, only continuing to do what we're already doing, only failing to change fast enough to coordinate globally, to sacrifice immediate comfort for long-term survival. It's a slow-motion apocalypse, and that might be exactly why we can't stop it. Then there's artificial intelligence. Not the AI we have now, narrow, specialized, bounded. The AI that might be coming. Artificial general intelligence, human level, or beyond capable of recursive self-improvement. An intelligence that can rewrite its own code, make itself smarter use. That increased intelligence to become smarter, still bootstrapping itself into capabilities we can't predict or control. This sounds like science fiction until you realize we're actively trying to build it. Billions of dollars in investment, thousands of researchers, competing nations and corporations, racing to be first, each one convinced they can build it, safely align it with human values, keep it contained and beneficial. But alignment, ensuring an AI shares human goals, is an unsolved problem. We don't know how to do it. We're trying to figure it out while simultaneously building the thing we need to control. And the timeline might be shorter than we think. Most AI researchers, when surveyed, estimate human-level AI within decades. some say less. And once you have human-level AI, the jump to superhuman might take days or hours. We're racing toward a threshold where we create something smarter than ourselves, hope it's aligned with our interests, and discover whether we were right only after it's too late to do anything about it. The pattern is clear. Every technology that gives us power also gives us the means to destroy ourselves. Every breakthrough creates new capabilities and new catastrophes, and critically, our wisdom doesn't scale with our power. We're still running. Stone Age brains evolved for tribal groups of 150 people, for immediate threats like predators, and starvation for timescales of days and weeks, not centuries and millennia. We're not adapted for the challenges we face. We're territorial when we need to be global. We're tribal when we need to be unified. We think short-term when we need long-term vision. We respond to immediate, visible threats while ignoring slow-building existential ones. It's not a moral failing. It's a cognitive mismatch between the brains evolution gave us and the world technology has created. This might be the great filter, not a specific technology that kills civilizations, but the gap between capability and wisdom. Every intelligent species eventually develops technology powerful enough to destroy itself. The question is whether they also develop the maturity, the foresight, the cooperation necessary to not use that power carelessly. Maybe most don't. Maybe the galaxy is quiet because civilization after civilization reaches this point: nuclear weapons, climate instability, AI, or something we haven't even imagined yet, and fails the test, not because they're evil, but because they're smart enough to create power and not wise enough to control it. Earth might be full of ghosts from our own future, civilizations that survived wars, plagues, asteroids, ice ages, only to destroy themselves the moment they became truly powerful. And we're walking that same path right now, accelerating toward thresholds we barely understand, hoping that somehow we'll be different, hoping that when the test comes, and it's coming, maybe it's already here, we'll pass where others failed. But hope is not a strategy, and time is running out. Yet, in the depths of this silence, in the shadow of these fears, perhaps there's a message we haven't yet heard. What if the quiet isn't mystery, but wisdom? What if silence is what survival sounds like? We've spent this entire journey treating the great silence as a puzzle, an anomaly to be solved, a question demanding an answer. Where are they? Why don't we hear them? What's wrong? But perhaps we've been asking the wrong question all along. Perhaps the silence isn't the absence of an answer. Perhaps the silence is the answer. Imagine you're a civilization that survived. You've made it through your nuclear age without destroying yourself. You've navigated climate change, or prevented it, or adapted. You've developed artificial intelligence and managed to keep it aligned with your values. Or you've decided some technologies are too dangerous to pursue. You've passed your great filter, whatever form it took, and emerged on the other side. Now, you look out at the galaxy with newly educated eyes. You've learned, probably through near-extinction experiences, how fragile civilization is, how narrow the margins are between survival and oblivion, how easily confidence becomes arrogance, and arrogance becomes extinction. And you understand with the clarity that only survivors can have that the universe is not inherently friendly. What do? Do you broadcast your success? Do you announce, "We made it, we survived," and hope others will celebrate with you? Or do you remember how close you came to failing, how many times your existence hung by a thread, and decide that the wisest course is silence? You go quiet, not out of fear exactly, though fear is part of it, out of caution born from experience, out of the understanding that in a universe where you cannot know intentions, where communication is measured in centuries, where mistakes cannot be undone, the safest strategy is to observe without being observed, to listen without speaking, to learn without teaching. This is what the dark forest predicts, and it's what we see: a galaxy that should be full of voices, but is instead perfectly quiet. Not because no one survived their filter, not because civilizations are impossibly rare, but because the ones who survived learned the same lesson independently, arrived at the same conclusion across thousands of different worlds and millions of years. Silence works, noise kills, and perhaps they see us young, loud broadcasting ourselves into the void with a mixture of pity and horror that wise elders feel watching a child play near a cliff's edge. They can't warn us without revealing themselves. They can't help without risking their own survival. So they stay quiet and watch, waiting to see if we'll learn the lesson in time or become another data point in their long catalog of civilizations that spoke too loudly and were silenced. The silence from this perspective is not hostile. It's not a threat or a trap. It's simply the natural state of a mature galaxy, a place where the wise have learned to be quiet and the foolish don't last long enough to be heard for more than a cosmic moment. And maybe that's why our telescopes find nothing, why SETI detects only static, why the most sensitive instruments we've built scanning thousands of star systems across decades of observation have never found even the faintest whisper of artificial signals. Because the civilizations that are out there, and they might be everywhere, thousands of them filling the galaxy with minds and dreams and art we'll never see, have all learned to hide. They've cloaked their planets, minimized their energy, signatures, abandoned loud radio broadcasts for tight beam communications or quantum channels we can't detect. They've become invisible, not through any single technology, but through a comprehensive philosophy of stealth applied across every aspect of their existence. They are the dark matter of civilization, present, influential, real, but utterly undetectable to our current methods. Think about what this means for us. We've spent a century accidentally shouting into space, and several decades deliberately listening for responses, becoming increasingly anxious that no one's answering. But maybe they are answering with silence. Maybe every empty frequency, every star system with no detectable radio emissions, every perfectly natural-looking planet is sending us the same message. Stay quiet. Be careful. The universe is listening. The silence is a warning written in absence. It's saying, look at the galaxy. See how quiet it is. See how empty it appears. That's not because life is rare. That's because the survivors learned not to make noise. And here's where the weight of our situation really settles in. We're the exception. In a galaxy of silence, Earth is shouting. Our radio bubble expands every second, carrying our location and our nature to anyone within listening range. We're the loud ones, the visible ones, the civilization that hasn't yet learned the first rule of cosmic survival. We're like someone who stumbled into a library where everyone else has been silent for centuries, and we're speaking at full volume, wondering why everyone's staring at us with such strange expressions, mixtures of pity, disbelief, and the look people have when they're watching someone who doesn't know they're about to make a terrible mistake. But maybe it's not too late for us to learn. Maybe the silence we hear isn't condemnation, but opportunity, a chance to observe and understand before we commit to a path we can't reverse. Every year, we continue listening without broadcasting intentionally. Every year, we develop better technologies for detecting others without revealing ourselves. Every year, we grow in wisdom, and caution is another year we might survive. The older civilizations, if they're watching, might be waiting to see which choice we make. Will we stay loud, convinced that hope and openness are more important than caution? Will we go silent, accepting the lonely wisdom of the dark forest? Or will we find some third path, something that preserves both consciousness and connection in a universe that seems to allow only one or the other? Perhaps that's the real test. Not whether we can survive our technology, not whether we can avoid destroying ourselves, but whether we can learn the discipline of silence while retaining the courage of curiosity. Whether we can be wise without becoming fearful. Whether we can survive without becoming merely survivalists. The great silence might be showing us what galactic maturity looks like. And the question facing us, the species, the civilization, the brief spark of consciousness on this small blue world, is whether we have the humility to learn from it. The universe is not speaking to us in words, but it's speaking nonetheless in the profound and absolute quiet of a galaxy that should be roaring with voices, but instead maintains a hush so complete it can only be intentional. And the message, if we choose to hear it, is simple and terrifying and potentially life-saving. Survive first. Speak later. Maybe never speak at all. The silence is not the mystery. The silence is the answer written in the survival of those wise enough to choose it. And somewhere among the stars, civilizations old beyond our comprehension are watching to see if we're wise enough to listen. But to understand why silence might be wisdom, we must first understand the mirror we're holding up to the cosmos. Every fear we project onto aliens is a confession about ourselves. When we imagine hostile extraterrestrials, when we construct scenarios of invasion and extinction, when we theorize about dark forests and cosmic predators, we're not really describing them. We can't be. We've never met them, never detected them, never confirmed they exist at all. What we're actually doing is holding up a mirror to humanity and describing what we see reflected back. The dark forest theory doesn't require aliens to be evil. It doesn't assume they're cruel or sadistic or enjoy destruction. It simply assumes they think like we do, that they value survival above all else, that they act in self-interest when faced with uncertainty, that they'd rather eliminate a potential threat than risk being eliminated by it. And we assume this because it's what we've done over and over throughout our entire history. Look at the record. Every time two human civilizations have met with unequal power, the outcome has been devastatingly predictable. When Europeans reached the Americas, they didn't just settle, they conquered. They enslaved. They spread diseases deliberately or through negligence. They systematically destroyed cultures that had existed for thousands of years. Within a century, empires that had rivaled anything in Europe were reduced to scattered populations and ruins. The Aztecs, the Incas, the civilizations of North America, they didn't fall because they were weak or primitive. Some had mathematics, architecture, and social organization that rivaled or exceeded their conquerors. They fell because they encountered something they couldn't predict or prepare for another advanced civilization with superior military technology and zero empathy for those they saw as obstacles. The pattern repeats across continents and centuries. British colonization of Australia, Belgian exploitation of Congo, the endless sequence of empires expanding, conquering, extracting, and leaving ruins behind. It's not unique to any one culture or time period. It's what technologically advanced civilizations do when they encounter less advanced ones and face no meaningful consequences for domination. We tell ourselves we've evolved beyond this, that modern humans are more ethical, more enlightened. But have we? We've just outsourced the worst of it, made it less visible. We don't enslave people openly anymore. We just ensure economic systems keep certain populations perpetually disadvantaged. We don't commit genocide as policy. We just allow it to happen when intervening isn't profitable or politically convenient. We've gotten better at public relations, not at actual empathy, and that's just within our own species beings, with whom we share DNA evolutionary history and the vast majority of our biology. When it comes to non-human intelligence, our track record is even worse. Consider how we treat other conscious, intelligent life on Earth. Great apes, our closest relatives, sharing 98% of our DNA, are endangered because we've destroyed their habitats for palm oil plantations and lumber. Dolphins and whales, with brains larger and more complex than ours, in some ways die by the thousands in fishing nets and from pollution. Elephants, with mourning rituals and family bonds that mirror our own, are poached to extinction for ivory. These aren't alien intelligences. These are minds. We can study behaviors, we can document suffering, we can observe directly, and still we drive them toward extinction because their survival is inconvenient to our economic systems. We don't hate them. We don't fear them. We just value our comfort more than their existence. Now extrapolate that to truly alien intelligence, beings with whom we share no evolutionary history, no biological similarities, no common frame of reference. If we can't extend empathy to dolphins, mammals, with whom we share hundreds of millions of years of evolutionary history, what chance is there that we'd extend it to something that evolved under a different sun, with different chemistry, different sensory systems, different everything? And more importantly, what chance is there that they'd extend empathy to us? This is why the dark forest feels so plausible, not because we have evidence of hostile aliens, but because we have endless evidence of how intelligence behaves when it encounters other intelligence. We compete, we dominate, we exploit, and we justify it with whatever narrative makes us comfortable. Manifest destiny, civilizing missions, survival of the fittest, economic necessity. We fear aliens treating us the way we've treated each other, the way we've treated every other species on this planet. We fear them seeing us as we see everything else, as resources, as obstacles, as things, rather than beings. And we fear this because deep down, we know it's rational. We know it's what we might do in their position. The chain of suspicion in the dark forest isn't paranoia, it's pattern recognition. It's looking at the only example of technological intelligence we have ourselves and asking, if we encountered aliens, what would we do? And then realizing that the honest answer is uncomfortable at best, horrifying at worst. Would we share resources equally? History suggests no. Would we respect their autonomy and culture? Not if it conflicted with our interests. Would we risk our own security to accommodate theirs? We can't even do that between human nations, let alone across species barriers. Some argue that advanced civilizations must be peaceful, that technological progress requires social cohesion and cooperation, that any species capable of spaceflight must have transcended violent impulses. But this is hopeful thinking, not logic. Cooperation within a group doesn't mean cooperation between groups. Ants cooperate magnificently within their colonies and wage brutal wars of extinction against rival colonies. Humans cooperate within families, tribes, nations, and use that cooperation to more effectively compete against other families, tribes, nations. There's no physical law that says technological advancement requires universal empathy. You can build rockets while being deeply tribal. You can split atoms while maintaining rigid in-group, out-group distinctions. You can achieve spaceflight while still viewing outsiders as threats or resources rather than peers. And perhaps that's what makes the silence so ominous. Because if the galaxy is full of civilizations, they're probably not that different from us in this fundamental way. They probably cooperate internally and compete externally. They probably value their own survival above all else. They probably view other intelligences with some mixture of curiosity and threat assessment, the exact proportions, depending on circumstances we can't predict or control. The dark forest isn't a theory about aliens being monsters. It's a theory about intelligence being tribalistic, self-interested, and capable of violence when it perceives threats, even potential hypothetical threats, that might not materialize for generations. And we know intelligence is capable of this because we are, and we're the only data point we have. Every scenario we construct about hostile aliens, the relativistic weapons, the sterilization campaigns, the cold logic of preemptive strikes, these aren't fantasies. They're extrapolations based on real human history and real human nature. We're not imagining what aliens might do. We're describing what we might do projected onto a cosmic scale. The mirror is uncomfortable because it's honest. When we fear the dark forest, we're not afraid of the unknown. We're afraid of meeting ourselves out there. Intelligence without empathy, power without restraint, survival instinct without moral boundaries. We're afraid that if we ever encounter another civilization, we'll discover that consciousness everywhere tends toward the same brutal calculus: eliminate threats, exploit opportunities, survive at any cost. And the truly unsettling part is that this fear might be justified, because if we're typical, if human nature is more or less what intelligence naturally produces under evolutionary pressure, then the galaxy might be full of civilizations exactly like us, cooperative within their borders, competitive beyond them, capable of great beauty and terrible violence often simultaneously. Maybe that's why the cosmos is silent, not because no one's out there, but because everyone out there is like us. And we know from hard experience that when civilizations like us meet, it rarely ends well for both parties. The dark forest is our own history, reflected back at us in the cold light of distant stars. And the question it forces us to confront is not, what are they like? But rather, what are we? Because the answer to that question might determine whether we survive first contact, either as the civilization that eliminates or the one eliminated. The fear is not irrational. The fear is memory dressed in starlight. Yet even knowing this, knowing what we are and what we fear, we still face the choice that defines our future. This story has no ending yet, because we're still writing it. And every choice we make now is a word in that final chapter. We stand at a threshold unlike any in human history. Behind us, a century of noise, of unintentional broadcasting, of lighting ourselves up in the cosmic dark without understanding what we were doing. Ahead of us, multiple paths, each leading somewhere radically different, each representing a fundamental choice about what kind of civilization we want to be. Path 1. Continue speaking. This is the path of hope, of stubborn optimism, of refusing to let fear dictate our relationship with the cosmos. It says, we are young, yes, but youth is not weakness. We've made mistakes, but we're learning. We've been violent, but we're also capable of profound compassion of art and music, and philosophy of love that transcends self-interest. On this path, we continue meet-die messaging to extraterrestrial intelligence. We don't just accidentally leak radio signals. We deliberately craft messages and send them to promising star systems. We build visible megastructures. We light up the galaxy with our presence, announcing ourselves loudly and clearly. We are here. We are human. We hope to know you. We do this believing or choosing to believe that any civilization advanced enough to reach us is also advanced enough to have transcended the brutal survival logic of the dark forest. That wisdom comes with age, that empathy scales with intelligence, that the universe, while dangerous, is not fundamentally hostile. This path offers connection, the possibility of joining a galactic community, of learning from civilizations millions of years older than us, of contributing our unique perspective, our art, our science, our strange human way of seeing things to a cosmic conversation. It's the path Star Trek imagined diverse intelligences meeting as equals, sharing knowledge, building something greater together, but it carries immense risk. If the dark forest is real, this path leads to our detection and potentially our extinction. Every signal we send is a flare in the dark. Every visible structure is a target. We're betting our entire species on the hope that whoever finds us first will be friend, not predator. The optimists argue the bet is worth it, that hiding forever means dying slowly in isolation, our potential forever constrained to one small world, our existence meaningless to anyone but ourselves. They say better to risk death reaching for the stars than to guarantee death by staying small, quiet, and alone. Path 2. Embrace silence. This is the path of caution, of learning from what the universe seems to be teaching us. It says the great silence is not a mystery, but a lesson. The wisest civilizations have learned to go quiet, and if we want to survive, we should follow their example. On this path, we stop broadcasting entirely. We shut down unnecessary radio transmissions. We develop technologies to mask our heat signatures, to make Earth look as natural and uninteresting as possible from a distance. We study the art of invisibility, learning to detect others without being detected ourselves. We become observers rather than participants, watchers in the dark forest, moving carefully between trees, never announcing our position, never lighting fires. We listen constantly, learning everything we can about the cosmos, while revealing nothing about ourselves. We might explore, but stealthily, sending small quiet probes to nearby systems rather than loud colony ships. We might even expand, but slowly, carefully, always maintaining the discipline of silence. This path offers survival. If the dark forest is real, silence is the adaptation that lets civilizations persist across cosmic timescales. The loud ones die young. The quiet ones endure perhaps indefinitely. We trade the possibility of connection for the certainty of continued existence. But it's lonely, profoundly, existentially lonely. On this path, we might never know if we're actually alone or surrounded by others equally silent. We'd spend millennia wondering, searching, hoping for contact, but never initiating it, never taking the risk. We'd become like submarine captains in enemy waters, holding our breath forever, afraid that one sound will bring destruction. The cautious ones argue this loneliness is the price of wisdom, that every civilization faces this choice eventually, and the survivors are those who choose carefully. They say better to live in silence than die making noise. Better to wonder forever than to know for certain in our final moments that we were wrong about the universe being safe. Path 3. Transcendence. There's a third option, less discussed, but perhaps most radical. Leave biology behind entirely. Upload consciousness into digital form. Abandon flesh and planets and physical presence altogether. Become patterns of information capable of existing anywhere. There's computation in quantum substrates in the fabric of space-time itself, in forms we can't yet imagine. On this path, we solve the dark forest problem by removing ourselves from its logic. We don't need planets that can be destroyed or resources that can be competed for. We don't need to broadcast because we're everywhere and nowhere simultaneously. We don't fear death because we've become difficult to kill, distributed, backed up, existing across multiple redundant systems. This path offers a kind of immortality, freedom from biological constraints, from planetary vulnerability, from the resource scarcity that drives so much cosmic competition. We could explore the universe not with fragile bodies, but as pure consciousness, riding light beams between stars, experiencing realities biology could never access. But it requires giving up something fundamental, our humanity in its current form. The warmth of sun on skin, the taste of food, the chemical reality of emotion, everything that makes us human, as we understand it, would have to be translated, simulated, or abandoned. We'd survive, but would we still be us? Would digital consciousness, no matter how sophisticated, have the same qualities that make human experience meaningful. The transhumanists argue that this evolution is inevitable anyway. That biology is just a starting point, not a destination. They say consciousness is what matters, not substrate. Better to exist as patterns of information than to die as patterns of carbon. Change is not death, it's transformation, the next step in intelligence's natural evolution. So where are we now? The honest answer, somewhere between all three paths, paralyzed by uncertainty and disagreement. We haven't committed to silence. Our planet still glows in radio wavelengths. Our signals still propagate outward. But we haven't committed to deliberate contact. Either Métis remains controversial, with many scientists arguing it's reckless, and transcendence is still mostly theoretical, decades or centuries away from being a real option. We're in the uncomfortable middle, making the choice by not choosing, letting momentum and accident determine our course rather than conscious decision. And perhaps that's the most dangerous position of all, not because we've chosen wrong, but because we haven't really chosen at all. The universe doesn't care about our indecision. Every day we delay our radio bubble expands another day's worth of light years. Every year we wait, more star systems enter the range where they could in principle detect us. The choice is being made whether we acknowledge it or not. And maybe that's the real test. Not whether we can survive our technology or pass through the great filter, but whether we can achieve the level of unity, foresight, and wisdom necessary to make a conscious, species-wide choice about our cosmic future. Because right now, no one's in charge of this decision. There's no planetary government, no species council, no mechanism for humanity as a whole to deliberate and choose. If someone decides tomorrow to send a powerful transmission to a nearby star, they can do it. If a nation decides to build a Dyson sphere or a beacon, they can attempt it. Individual decisions made by small groups affecting the entire species forever. This might be part of the filter to the inability of young civilizations to coordinate at the scale necessary for survival. We're still thinking tribally while facing cosmic challenges, still operating as separate nations while needing to act as one species, still prioritizing short-term interests while facing questions that span millennia. Perhaps the civilizations that survive are those who learn to think and act as unified wholes, who develop the social technology to match their physical technology, who can say we and mean their entire species, not just their tribe or nation or ideology. We're not there yet. Maybe we never will be. But the clock is ticking, measured in light years, and radio waves in the expanding sphere of our presence and the shrinking window of our choices. This story doesn't end here because it's not over. Every day we write the next page. Every choice to broadcast or be silent to hope, or to fear to hide, or to shine is a sentence in the narrative of human existence. We don't know yet how this story ends, whether we join the chorus of ancient voices, whether we stay quiet and survive in shadows, whether we transform into something beyond recognition, whether we simply cease another brief spark extinguished in the infinite dark. But we know this, the ending is not predetermined. It's not written in the stars or encoded in our genes. It's a choice, maybe the only choice that truly matters. And as you lie here, in this quiet moment, under whatever sky you call home, you're part of that choice. Your fear and your hope, your caution and your courage, your voice in the conversation about what humanity should be. And do it all matters. Because civilizations aren't abstract things. They're collections of individuals, each one adding their weight to the direction of the whole. The dark forest is not out there waiting to judge us. We are in it now, have been for a century, making decisions that echo across light years and centuries. And the question isn't what's hiding in the dark. The question is, who do we choose to be while surrounded by it? Speakers of light, hoping against hope, for friendly answers, silent survivors, patient and hidden, transcendent minds beyond the reach of forest predators, or something else entirely, some fourth path we haven't imagined, yet some way to be both cautious and connected, both hidden and heard. We don't know, but we're about to find out. The universe is listening, and we, loud, young, hopeful, terrified humanity, are still deciding what we want to say, or if we want to say anything at all. The stars remain silent, and in that silence, we hear only ourselves whispering in the dark, hoping someone kind is listening. Close your eyes now. Feel the weight of your breath, the quiet of this moment. Somewhere above the stars still burn. Our signals still travel outward, unstoppable. And perhaps, someone is listening. We don't know if we're alone or surrounded, if silence means safety, or if we've already been seen. But we're here, still wondering, still hoping, still afraid. And that's enough for now. Sleep well, traveler. The forest is dark, but you're not walking through it alone. We're all in this together, waiting, listening, choosing. Good night.